All right, welcome to Calc 2. We are in the middle of doing our test reviews here. I did get one question on integration by parts problem. We're going to hit that one first. I get this one up in time, and I've been trying to be good this week. So tomorrow should be the latest I get this up. But overwhelmingly, they've looked at your quizzes, and you guys really seem to prefer the multiple choice. So I think we're going with multiple choice. That's what everybody wanted. Okay, we do maybe one or two fill in, do your own work thing, but I knew this was going to be an issue, that the editor is not the nicest thing in the world, so I'm not really that interested in going with it. And if I do a fill in the blank one, where you have to just pick a number and go with, I will do my best to make sure that that is, like a 2 decimal number kind of a thing, so that you can't, the formatting is not going to be a problem. Okay, so yeah, I listened. We're good. I will try to accommodate and make quizzes, make tests that we can all be happy with. That being said, I have not written your test yet, and I'm not good at writing multiple choice questions just yet. I'm still working on it. I tried to do a couple this morning, and came to the realization that all of them have way too many steps. So, multiple choice, you got to go with only a couple of steps. That being said, I probably will do a lot of setup but do not solve kind of problems, okay? Especially when we get to the partial fraction stuff. So just to give people an idea of, what I'm looking at, that's the kind of thing that we've got. That being said, let's look at a problem that will not be on a quiz because it is way too long. But it is a nice question. It is a nice question, and somebody did ask about it. So what we have is integration. Okay. And we have what do we have here? We have a 1 to 7, so a definite integral. We have a natural log of x, quantity squared, right? So one thing I would do with my algebra classes, I would say, is there a difference, right? One of them, you take the x, you square it, take the natural log. The other one is you take the natural log and then you square it. So these are different. Okay? And then underneath here, because we just can't have that, that'd be way too easy, x cubed, and then dx. Okay, how delightful. All right, this is kind of a polynomial. It's not really a polynomial, but it's an easy derivative to take, right? Times a logarithm. Okay, you got a logarithm times something that's easier. So here we are going to let u equal our natural log x squared, and our dv is equal to x to the -3, right? Can I change that to -3? dx. All right, and now we're just going to go through with our integration by parts problems here. We're going to have du is equal to 2 natural log x times 1 over x, right? Because we got to chain rule this thing. And then dv, right? We're going to add 1. Remember, we're adding 1. Okay, that's x to the -2, and there's a -1/2 out front. X next to the -2 divided by -2. When I was working this problem, the signs seem to be the handicap. Okay, that's where everything went south. Was when you lose track of those signs, you're stuck. Okay, so we're going to make our little box here. So we have our uv. So that is -1/2. What did I say here? -1/2 x to the -2. We have natural log x squared, right? And then this is minus integral of, well, let's do it this way, of 2 ln x, right? That's this part, times x to the -1, that's here, times -1/2 x to the -2. These are all times. Okay, sorry about that. All right, so this whole thing, these are all times. There's a negative here, there's a negative here. I'm going to go ahead and change that. So we have -1/2 x to the -2 ln x squared plus, because negative times negative is going to be a positive. And then look here, right? Look what happens at my 2's here. Okay, we have a 2, we have this, we have this one, we have this one. Okay, those cancel well. Multiplied together, we made a positive. Okay, and we have integral, right? And we have ln x times, oh, look at that, x to the negative 3 again. Delightful. So we have to do integration by parts again. So we're going to say that u is equal to ln x, because why not? Du is equal to 1 over x. Okay. dv is equal to x to the negative 3 dx. And v is going to be x to the negative 2. And we have over negative 2. Okay. And there's our, again, there's our integration by parts. So let's remember this part. So we've got negative 1/2 x to the negative 2 natural log x squared plus, and now we've got uv. So this is actually a minus, right? Minus 1/2 ln, oh, do it that way. 1/2 x to the negative 2 ln x. All right, minus integral, and then, oh, thank goodness, right? This is negative 1/2 x to the negative 2 times x to the negative 1, x to the negative 3 again. That's okay. The nightmare is over. We're almost done. Okay. So here we have negative 1/2 x to the negative 2 ln x squared minus 1/2 x to the negative 2 ln x, minus a minus, so plus, okay, plus 1/2 integral x to the negative 3 dx. 1, 7. Let's go ahead and integrate that. X to the negative 2, there's a minus 1 over 2 times 1 over 2. Okay, we have negative 1/2 x to the negative 2 natural log x squared minus 1/2 x to the negative 2 ln x, and then we have this business back here. Okay, and we're going from 1 to 7. Okay. So let's see here. What can we do? We can, let's take negative out. Okay, let's take a negative out. Did I do anything else that was clever? No, I wasn't that clever. Here, we're going to take the negative out. And we have, so you can take an x squared out, right? Negative, you can take that out. But since I'm going to be dealing with evaluating in a minute here, we're going to leave that alone. Okay. We could take the 1/2 as well. Right? We can take a negative 1/2. Okay. And then here we have x to the negative 2 ln x squared. We took the negative out, so I changed the sign, plus x to the negative 2 ln x, right? And we took the negative out, so we have plus 1/2 x to the negative 2. We had 2 1/2s here, so one of them put out, one of them came out, the other one still remains, 1/7. Now, what I'm going to do here to make the signs just a tad easier is I'm going to change that to a plus, I'm going to change that to a 1, I'm going to change that to a 7. Okay, so you're allowed to do that. It's a terrible contrast. I'm going to change that to a 1, change that to a 7, and made this a plus. Okay, so you're allowed to do that. You're allowed to swap the signs of your integration if you swap where the limits go. Okay, that's a thing you can do, is integral from a to b of f of x dx is equal to negative f from b to a, or integral b to a of f of x. So you're allowed to swap the integration if you put a negative sign out in front. Okay, why did you do that? Well, because it's a little bit easier and I don't have to carry around a bunch of negative signs. Okay. So let's see, we have, how about we do x evaluated at 1. Okay, so we have 1/2. Here we have 1 over 1 squared times natural log of 1 squared plus 1 over 1 squared times the natural log of 1 plus 1 over half times 1 over 1 squared. Okay. So you could see, right, you type, if you don't believe this, you could type this into the, right, you type this into the calculator if you'd like. Check out natural log of what? Right, what are you going to find? That's a 0, that's a 0, okay? So what we have here is a quarter, right? Half times a half. This is equal to a quarter, all right? Now, what do we have for the next part, right? We have minus half, right? Oh, half times a half, that is not a quarter. Half times a half is a quarter. And I said, why did I say, I know I said a quarter, and then I wrote down half. What am I thinking? There, that was easy to fix. All right, so we have half. Oh, this is minus because of the x evaluated at 1. This is x evaluated at 7. So we're subtracting, right? We have 1 evaluated at 1 minus the 7. All right. And then here we have 1 over 7 squared, natural log of 7 squared, plus 1 over 7 squared, natural log of 7, right, plus 1 over 2 times 1 over 7 squared. Right? So you see where that all came from? We're evaluating, we're putting x is equal to 7. Okay, that's what happened there. All right, so we have minus a half. I'm going to hold this outside for just a moment longer. We've got 1 over 49 natural log of 7 squared minus 1 over 4, that's a plus. That's a plus. 1 over 49 natural log of 7 plus 1 over 2 times 1 over 49 times this 1/2 out in front. Okay, so here's my top part, right? This is 1/4. This is here. Minus 1 over, what's 2 times 49 is 98. Natural log of 7 squared minus 1 over 98 natural log of 7. And then minus, because this is a plus, right? This is a plus, so minus half times a half is a quarter. I'm not going to multiply this out because I want to be able to add some fractions, okay? So I'm just going to hold this off to the side until we're done. What are my like terms, right? What are my like terms? So I've got like terms. I'll use pink, it's fine. We've got, this is a like term. This is a like term. This is nothing, okay? So what we have to do next is we have to figure it out. Right? What is 1/4 minus 1/4 140? This is really 1 over 4 times 49. Okay, let's write it that way. All right. So the reason I did it that way was simply so that when I want to get my common denominator, I don't have to think about like, whatever do I multiply this by? Okay, so we have 49 minus 1 over 4 times 49 here. And we end up with 48 over 4 times 49. It's 48 over 4, right? Isn't that 12? This is all times, by the way. 12 over 49. Okay. So in the end, we have 12 over 49 minus 1 over 98 natural log of 7 squared minus 1 over 98 natural log of 7. I'm sure this is a delightful looking number. All right. But you know, that's how you do it. I will be honest, I messed a sign the first time I did this one. So you know, there's something there. What I learned, because I was like, oh, what a whole problem. This would be a great multiple choice question. And then I lost a sign about somewhere in the page of Joule of Algebra that came with this problem. I said, that is a terrible multiple choice question because that one tiny little mistake is going to cost somebody a whole problem. So I like this problem. I cannot ask it on a multiple choice question because there's too many moving parts, okay? So if you're terrified of seeing one like this, okay, I subject myself to the same stuff. If I'm losing signs and that's giving me the wrong answer, like, maybe we should try something else. Okay, all right. So there we go. That's that problem. Now the next one I have is one that I pulled off of a previous quiz. And you'll see why this one is terrible too. But I've got something set up for this one. Oops, where's my start? Already, that's a bad sign, right? Like, where did I start this? All right. That's the other problem. All right. So this problem, 1 to 2, right? And then we have a 4y squared. This is actually one out of your homework, I think. Okay. I'm pretty sure this is one out of your homework. Okay. And then we have a y plus 2, and we have a y minus 3. Okay, dy. So indulge me because I teach college algebra a lot, teach pre-calc a lot. So one of the things that I'm looking for when I see a problem like this is I'm wondering if it cancels with anything on the bottom here. Okay, so it makes a whole, right? If we wanted to integrate like x squared from 0 to 1, but I had like x is not equal to 1/2, then all we would have, right, is something like this. In that one point, so you have to take the area. So here's, let me blow this up a little bit. Okay, so here's what we would actually have. We would have, so x is not equal to 1/2, all right? So graphically, geometrically, right, we have x equals 1/2. Here's 1, here's 1. 1/2 squared is a quarter. So there's my dot, there's my hole. Okay, we're going to learn more about these in the next chapter. They're called improper integrals. Okay, this one, not really an improper integral. Okay, you can see why. Technically, we got to divide this up into 3 integrals. Okay, we're going to go from 0 to 1/2 of x squared dx plus 1/2 to 1/2 of x squared dx plus 1/2 to 1 x squared dx. Okay, that's why this one doesn't really count. All right. So what we're trying to do is figure out what's the area under the curve here, right? So I gotta exclude that spot, right? Pretend that lines up. And I don't know if you remember your high school geometry very well, but what's the area? You know, if we have a line here, what's the area of this line? Or with the calculus, right, with your new and improved tools, what's the integral from a to a of any function? 0. Okay, so just because we have a skip, you know, if we wanted to be real formal, this is how we would write it. But usually people just kind of avoid this skip and not really worry about it because there's no discontinuity here. There's no like weird stuff going on, right? It's just a removable discontinuity. So we're not really going to worry about this. We just integrate it. Again, you wanted to break it up like this, that's okay. That's probably that's the formal thing to do, but we wouldn't worry. But here, right, if we could break this up, if I could cancel something here, then, oh, this would be so much easier, wouldn't it? So we want to do that. We want to check. So we usually use AC method, right? See if this factors. So 4 times 12 is 48. And then does any factors of 48 add up, have a difference of 7? 4 and 12, like the last problem. 6 and 8. Okay. Any of those subtract that to be 7? Nope. Okay. So we got, pardon me, we are stuck with this problem. Okay. It's delightful. So let's see here. What we're going to say, because I can't integrate this, and I certainly do not. And I do not want you to multiply this out and then see whether or not the bottom is you, and then this happened to turn into, no, we don't want to do that at all. No. All right. So what we have to do is we have to make a partial fraction, right? We have to say, well, we have 3 linear terms. So we have an a over y plus a b over a y plus 2 plus a c over a y minus 3. Okay, equals, and this is 4y squared minus 7y minus 12 over this stuff, minus 3. Okay, because we're trying to set this down. So what we're going to do next is we're going to multiply by the denominators, because that's what we always do when we try to have a rational equation. So we have an a. If I multiply by the denominator, the y's cancel. Y plus 2, y minus 3. Plus b, y minus 2 is canceled, so by, y minus 3. Plus c, this is going to cancel, cy, y plus 2. Okay, and this is equal to 4y squared minus 7y minus 12. I haven't really decided like where is the good thing to stop at for setting this up. Might be here, right? Set up the partial fraction equation to integrate this function. You know, that would be the problem. That would be the answer right there. I'm not trying to fool you by picking this versus this. Okay, that's not what I care about. All right, because this is naturally the next step. I do not want to try to say, oh, I got you because you went a step further than I asked. Like, no, that's not it. But what I will try to fool you on is like doing a, you know, can I do a by plus c over y plus 2 kind of stuff? Okay, so it's, did you set up the proper did you set up the improper fraction, the partial fractions correctly? Not what step do you stop on? I think that's a terrible way to ask a multiple choice question. Okay, but we're just going to keep going here. This might be a good place to stop. We have a squared. Oh, that's a minus. All right, minus a y, right? Because we have plus 2 minus 1 minus 6 plus, I'm going to leave this alone for just a moment. We've got y squared minus 3y plus c, y squared plus 2y equals 4y squared minus 7y minus 12. And then if I want to set this thing up, right, we've got a y squared minus a y minus 6a plus by squared minus 3b y plus cy squared plus 2c y is equal to 4y squared minus 7y minus 12. Okay, so now we're going to equate coefficients. We need all the stuff with a y squared in it. That's going to be y plus b plus c is equal to 4. For y, we have minus a minus 3b plus 2c is equal to minus 7. And for my constant term, we have negative 6a equals negative 12. Okay, this is the other stopping point I thought about. Okay, as far as like how much work should you be doing for this one? Okay, so this was my worst case scenario for set up the system of equations and let it go. Okay, so that is another possibility. All right. Okay, For us, though, we're just going to solve this thing, okay? So we have, hey, we got one equation that looks like it only has one variable in it. Why don't we solve that one? So a is equal to negative 12 over negative 6. Hey, a is 2. Now, this is why I put this one on the quiz last year, was because once you got this, you didn't even need a calculator, right? You had 2 plus b plus c is equal to 4. And we had negative 2 minus 3b plus 2c is equal to negative 7. So this is b plus c equals 2. I add 2 over here, right? We have negative 3b plus 2c is equal to negative 5. So even though it looks like it's like a 3-variable equation with 3 unknowns, and it's going to be a horrible mess, you got the matrices and Kramer's rule and every other thing known to man to solve this thing. Now it's a was 2. Okay, we're going to use that, and then we're just going to solve this 2 by 2 equation here. All right, let's multiply the top by negative 3. Oh no, by positive 3. Positive 3. Because I want the b's to cancel. So we're going to have 3b plus 3c is equal to 6 minus 3b plus 2c is equal to negative 5. Add them, we get 5c is equal to 1. C is equal to a fifth. Again, this is several steps beyond where I would ask you to stop if I were to put something like this on a multiple choice test. Okay, so we are way outside the bounds here. But now that I have c is equal to a fifth, let's go back up here. We've got b, right? This is from equation 1. This is from equation 1. b plus 1/5 is equal to, can I say that 2 is really 10/5? Is that okay? And then b was going to be 9/5, right? 10/5 minus 1/5 is equal to 9/5. Okay, now back up about a page, okay, or 2. This is all going to be, right, this was equal to, right, we have 4y squared minus, what was it, 7y minus 12? Yeah, y plus 2, y minus 3 dy. This is really the same integral 1 to 2. This is really the same integral as 2 over y, okay, plus 1/5, 1 over y plus 2. Oh, it was 9/5. Let's make this a 9. Okay, plus 1/5, and then we have a 1 over y minus 3. So now we just have to integrate these 3 pieces. Okay. Oh, is there a difference between, right? Is there a difference between 9/5 over y plus 2 or 9/5 times 1 over y plus 2? Right, there is no difference. I always found this just to be a little bit easier to think about and integrate. With this one, there's certain problems where I got a little screwed up because of this wasn't a nice number. Okay, so when I started pulling them out to do my integral, right, because it's just a constant, we can slide that through. That might help you. You might look at this and say, yeah, I never cared. Okay, this is too easy. I'm not going to worry about it. But that's fine. But if you're having trouble seeing it, move that 9/5 out in front of the integral and then just integrate the 1 over 2. That's why I write it this way. Okay, to me, it makes it a little bit more clear. But that's my preference. Okay, you write it any other way you'd like. So this is 2 natural log of, now we're going to need absolute values here, so I may not write them all the time because we really only need them right here. Because 2 minus 3 is a negative number, 1 minus 3 is a negative number. That's where we're going to need that absolute value. Okay, and if you ever wondered, like, why do we need the absolute values? Now you know. All right, there's the spot. Okay, let's go ahead, evaluate. Y is equal to 2. we have 2 ln 2 plus 9/5. ln 2 plus 2 is 4 plus 1/5. Natural log 2 minus 3, right? -1, right? 2 minus 3 is going to be -1. Okay. Evaluate y equals 1. Okay. So we have 2 ln 1 plus 9/5. ln 1 plus 2 is 3. This is 1 plus 2 because 1, and then plus 1/5. And then we have natural log, right? 1 minus 3, absolute value -2. Now remember, we're subtracting that. Okay, we're taking the top, y equals 2, this piece, okay, minus that piece. Okay, that's all we're doing there. Okay, what is the natural log of 1? Natural log of 1 is 0. The natural log of 1, because the absolute value of -1 is +1, and the natural log of that, you're gone, that's gone. Okay? So now we have 2 natural log 2 plus 9/5 natural log 4 minus 9/5 natural log 3 plus 1/5. Nope, it's still a minus, isn't it? Minus 1/5 natural log 2. Once I've taken the absolute value, we don't really need that anymore. So I got a lot of weird stuff going on here. I'm going to go ahead and say that 2, or 4 rather, is equal to 2 squared. So the natural log of 4 is going to be the natural log of 2 squared, which is 2 times natural log of 2. So we're going to have 2 ln 2 plus 18 over 5. Natural log 2, 9 times 2 is 18, minus 1/5 natural log 2, minus 9/5 natural log 3. And you can't combine natural log 2 and natural log 3. It's just not going to work. Oh, 2 is 10/5, isn't it? We have 10 plus 18 minus 1. 27/5 ln 2 minus 9/5 ln 3. The only thing I did after this was I just took a 1/5 out. So I'd have 27 natural log 2 minus 9 natural log 3. And that was my answer. All right. But to reiterate, working through this problem, because I have to work through them. I can't just pick them and say, here, do it. I got to come up with them. Understand that I don't give Facebook multiple choice questions, right? If I'm going to ask you, like, what's the integral of, 1/3 x to the 4th, right? Then the answers are going to look like, they're not going to be this, A, Philadelphia, B is, what are we going to do here? We're going to do 1/15 x to the 5 plus c. B, C is going to be 4/3 x cubed, and then D will be Socorro. Okay, I don't do those kinds of multiple choice. Okay, this answer and this answer are good ones. There might be one without a C in it, right? I'll try to put 2 with C's, 2 without C's maybe, but maybe 3 with C's in them. But I'm going to try to find places where I'm going to try to trick you a little bit. All right. Now, this one, there's not a lot of tricks, except for this. Okay, but that's about all we got. Okay, so realize, multiple choice are going to be, real. I'm not going to give problems like this. At least I'm going to try not to. And that's how we're going to go. That being said, check your, any problem where, like, what if you have to do integral of like inverse sine of x? See, now this would be a good multiple choice question. I might even put an A and a B in here, because the let u is equal to sine inverse dv is equal to dx, right? du is equal to 1 over square root of 1 minus x squared. V is equal to x. Okay, so there we go. So we have x. I don't know what's going on back there. Clearly there's a cat that is doing something. Okay. Okay, x. Okay. I'm going to go ahead and do this. All right. Why would I do that? Because my next step here, let w, let t equal 1 minus x squared, and dt is equal to negative 2x. Hey, I already got a negative in there. So all I need to do, okay, all I need to do is put it, right, here's my negative. I'll put a 2 here and a 2 there. That'll cancel. So here is my, right, dt. And then I've got t to the negative 1/2 here. Got a 1/2 here. Okay, integral. And then we have x sine inverse x plus, okay, so we have x sine inverse x plus 1/2, right? This is going to be t to the 1/2 over 1/2. Boy, that's nice, isn't it? Evaluate it from A to B. There'll be numbers. I'm not going to just put A and B in there. That's not right. All right, so we'll do this. So the half cancels with a half. And here we go. This is x sine inverse x plus, the heck was t? T was 1 minus x squared. We're just going to evaluate from A to B. Right? So that struck me as a reasonable, or plus c, right, if it was indefinite. That struck me as a reasonable multiple choice question to make you go through and do. There's a couple of steps, but it's not, there's not a lot of SIG and sign errors you can make. Right? It's one step, so we're not doing everything. And it's a pretty straightforward and honestly pretty standard type of a problem. So this would be a multiple choice question I would pick. All right. So with that, I'm going to go ahead and stop us there. I will do more volume through revolution tomorrow, both shell method and cylinder method, so you can see what the difference is. When I don't enforce this, I don't tell you, you shall do it this way. Okay, I don't like to do that, because knowing calculus is being able to have choices, how you want to solve the problem. But, that canonical problem, right? Something like that, and it's going to rotate around here. You do not want to take this function minus that function, right, and do cylinders. You want to do shells and do it this way. Okay, so when I want you to do a shell problem and you graph it, and you should, okay, and you get some kind of crazy thing like that, realize I do not want you. I mean, I'm not going to stop you. You can. It's just, I'm not going to be responsible for, like, I just took 45 minutes on this problem. Like, yeah, I know. That's the problem. So realize, like, when you have an outside minus an inside, and they're like the same function, right? They're like y equals x squared 1 minus x kind of thing. Like, this is, you don't want to solve for this. You don't want to put this in terms of y, so you could go ahead and do it this way and have dy's for cylinders. You want to let it be dx's and rotate them around. Okay, so again, I know the volumes, the revolution stuff, I know those are insanely hard. So I'm not trying to come up with the hardest problem you've ever seen, but do understand, like, when would you want to use a shell here where you don't want to have to solve for x, and when would you want to use a cylinder? Okay, so practice that. I'm also not trying to, if you see a problem where it's rotated around the line y equals x, I am never asking you that problem. I mean, especially on an exam. That is a terrible problem. Okay, there's a lot going on with this. So we're not rotating it around this. Okay, so it's going to be an axis. It might be, I could do. I don't like to do shells like differently, but cylinders, we could, do something like that. Rotate it around. Maybe not this point. Maybe we'll take a y equals -1 and rotate it around that axis. Okay, so if you see a cylinder where you're rotating around different, you might want to practice those. But shells are kind of weird. I know, they're hard. So I'll pretty much pick a straightforward problem for a shell. So don't go looking for the hardest problem here. Go looking for, I don't want you to. I don't want you to have to do like a ton of work on every one of these things. And for those problems, it might be set up but do not solve. Okay, because once you have the setup, like there's, picking the integral it's not really that big of a deal. Okay, I'm going to stop there, and I will try to get this up by tomorrow and maybe tonight, and then we'll go and do more. Okay, but I haven't written it yet. Sorry, but I will be trying to make sure that most of them are multiple choice. All right, thank you.